following is a strong electrolyte but not a strong acid in aqueous solution? And this would be a multiple choice question for you. And what I'd like to do is I'm just going to go through all of these because within this homework question, you're going to get questions about strong electrolytes, strong acids, weak electrolytes, weak acids, and the like. So it seems like a good opportunity to go over a number of things. First off, let's start with HBr. So HBr is an acid. It has an H in the front. Can anybody tell me if HBr is a strong or a weak acid?
Strong.
It is a strong acid, and there are only 7 strong acids, and I've asked you to memorize them. Let me list them now. So there are 3 of the 4 halogens with H. So HCl, HBr, HI. Not HF though, which is always fun. Then we get nitric acid, HNO3, sulfuric acid, H2SO4, and the HClO3 and HClO4. So these are the 7 strong acids. It will definitely help you to memorize those. As when you go through acids, you will, these are the acids that are the only strong ones. So there are thousands of weak acids. There are only 7 strong ones. So we just said HBr is a strong acid. And all strong acids are also strong electrolytes. And so our idea of a strong acid is that a strong acid breaks up 100% into H plus and Br minus. And our idea of a strong electrolyte is that it breaks up 100% into ions. And so hopefully you can see that it's a strong acid because it breaks up 100% into H+, and it's a strong electrolyte because it breaks up 100% into ions. Now, any questions about that? Okay, so let's go on to sodium fluoride. So sodium fluoride, the first thing we notice about this is that it has a sodium. Sodium is a metal. If we look at our periodic table, we hopefully remember that all of the elements all the way over to the left from the zigzag line are metals, and sodium is way over here, so it is definitely a metal. Another way of thinking about it is that metals form cations. Those are positive ions. So either way, we know that this is Na plus and F minus, F being a non-metal forming a negative ion. So, and it is important, and one of the continuing themes in this course is that we need to know that this is an ionic compound. And we know it's an ionic compound because it has Na, it's made of ions, Na plus and F minus. Okay. And for ionic compounds, there's only 2 choices. For the ways in which we'll describe them. One is that it's a strong electrolyte. And the other is that it is insoluble. Okay? And the strong electrolyte dissolves and breaks up 100% into ions. And if it's insoluble, then it doesn't dissolve. Now it turns out that according to our solubility rules, which are on your nomenclature sheet, and your nomenclature sheet is under syllabus and course schedule. And if you look at your solubility rules, it says all common compounds of group 1 and ammonium ions are soluble, and sodium is in group 1. So anything with a sodium in it is soluble. And let's see, only two choices. Oh, soluble, then it's a strong electrolyte. Or you'll be asked sometimes if ionic compounds are soluble or insoluble, and insoluble ones are just listed as insoluble. They don't dissolve. They are also known as solids, so we'll classify those as solids. And so sodium fluoride is a strong electrolyte, but not a strong acid. So that is the answer you're going to want to circle here. Or in this case, click on strong electrolyte. Continuing on, so, and just so you know, we have our answer now, but HClO is an acid because it has H in the front. So it is an acid, but it is not one of our 7 strong acids. I know it's very close to one of our strong acids, but HCl and HClO are entirely different compounds. So H in the front, it is an acid, so not a strong acid because we memorized those, so must be a weak acid. And weak acids are also strong electrolytes. Or sorry, hold on. Weak acids are also weak electrolytes and a weak electrolyte. And if you remember from the videos, so a weak acid is a weak electrolyte because it breaks up less than 5% into ions. And those ions would be H pluses, and in this case, ClO minuses, okay? Let me do one more, and then I'm happy to take questions about this or anything on this. So C6H12O6, that's the formula for glucose. And you'll notice there are no ions here. There are no metals. There's nothing that we are typically identifying with a charge here. So, and these are all nonmetals. And for substances that contain all nonmetals, there are only two choices. So something like C6H12O6, which is glucose, which is a sugar, so it will dissolve, but will not break up into any ions, or the way I like to put it is will dissolve and stay as whole molecules. And so no ions. And our term for a substance that does that is a non-electrolyte. And so to be either a non-electrolyte, a weak electrolyte, or a strong electrolyte, you must dissolve. So any of the kinds of electrolytes dissolves. The question of whether you're non, weak, or strong then depends upon how many ions you break up into. So non-electrolyte has no ions. Strong electrolyte is 100% ions. And a weak electrolyte is less than 5% ions. And sometimes much less than 5%. We don't specify the number We just say less than 5%. So, okay, but there's other things that have CH and O in them. And as a counterexample, let me show you this. CH3COOH. So that has COOH in the back. And that is your clue, clue, yeah, I think clue is a good word, that this is a weak acid. Because acids are so important, we have two ways of designating them. One with a COOH in the back, and we'll see that this is for acids such as citric acid, lactic acid, the amino acids that are in, that make up proteins will all have the COOH group in them somewhere. And then of course we've already talked about if it has an H in the front, how that's also a sign that you have an acid. Acids are just so important to us. So the COOH group in the back means it's a weak acid and a weak electrolyte. And for the compounds that you're going to see, if it contains just carbon, hydrogen, and oxygen, these are the only two things you will see. Compounds that have COOH in the back, those are weak acids and weak electrolytes, or just what looks like empirical formulas and molecular formulas from previous questions that we've done that doesn't tell you anything other than how many carbons, hydrogens, and oxygens there are. These are going to be non-electrolytes. Okay, I think I finished what I want to say about this. Are there any questions about it? I guess I can write up here non-electrolyte too. Okay.